All right, in this video we're going to talk about solving double inequalities. Now often when it is actually possible to write two inequalities as something called a double inequality. A double inequality would be something like when we try to put these two together. So here we see 5x minus 2 is greater than or equal to negative 4. On the other hand though, so if we write that down like this, we have that. But then we can also incorporate this by putting the less than sign here. Okay? And this makes complete sense. However, sometimes even if, so the first thing you have to make sure is that both these inequalities go the same way. The second, in other words, negative 4 is less than this, is less than or equal to this, but still less than, so same direction, than 7. However, what if we had these? Well, these, they do go the same way, but you end up with trying to put these together. You end up with 3 is less than x is less than or equal to negative 1. And when you do that, that doesn't really make sense because 3 is actually greater than negative 1. And so this makes no sense. This is just nonsense to write down. Because inequalities are transitive. Namely, if a number is less than this number and this number is less than or equal to this number, then this number has to be less than that number. But clearly that is not the case. So by solving to solve a double inequality, it's actually really easy. It's basically just like solving two inequalities all at the same time. So let's go through an example of this. Namely, if we wanted to solve something like negative 3 less than or equal to 6x minus 1 is less than 3. What we can do here is we can just pretend like we're going to solve all the inequalities all together. So in other words, if I subtract something from add or subtract or divide or multiply anything from one of these, I have to do it to all three. Okay? It's kind of like three sides to it, which doesn't really make sense, but yeah. So we want to get x by itself, so let's go ahead and add 1 to everything. When we do that, those cancel. Adding the 1 here gives me a 4. Adding preserves inequalities, doesn't matter whether it's positive or negative. And then we have negative 2 on that side, adding 1. So now we want to divide by 6. Since 6 is positive, we don't have to flip the inequality signs. And when we do that, we get negative 2 over 6, which is negative 1/3. Here we just have x. And here we just have 4 over 6, which is 2/3. In other words, as an interval, if we were to write that, it's worth noting that we could write this as an interval of the form negative 1/3 closed parentheses up to 2/3. Open parentheses because we don't include it. Graphing it is the same either way though. If we graph the inequality, what we have here is if this is negative 1/3, then this would be about 0. And then this would be about, so that would be positive 1/3, that would be about 2/3. What we would have is we can include negative 1/3, so let's shade that in. We don't include 2/3, but then we shade everything in between. Okay. And now it's time for you to try an example, so go ahead and solve the inequality provided there and graph the solution set. On the count of 3, I'll reveal the solution. 1, 2, 3. And so here's your solution. For more practice in solving double inequalities, be sure to see the book page A64 and work problems number 3 and 31 through 42. In our next video, we'll be working with absolute value inequalities.